Hi guys, in this video we're going to talk about the uDraper binding functionality and try to explain what it is and how it can be used. We'll start with the basics and move toward more advanced cases. To explain what binding is, let's start with this 1 by 1 meter cuboid mesh and a 50 by 50 centimeter square piece of cloth parallel to the front cuboid's wall. The binding tolerance is set to 0, which means no binding is applied to the cloth. If we start the cloth simulation, the cloth will fall to the floor. If we turn the gravity off and start the simulation again, the cloth will hover in place, and we can move it with our cursor. Let's set the binding tolerance to 20 mm while leaving the stiffness set to 1. To see the binding effect in 3D Draper, we need to start the simulation for the first time and let the clothes settle or drape freely. Then we should stop and restart the simulation. This time the binding kicks in. In our example, when we start the simulation, we can't move the cloth from its original position anymore. We have our cloth 100% bound and all its faces won't move from their positions relative to the surface of this cuboid. Let's now turn the gravity on and start changing the binding distance and stiffness. Once we've increased the distance and lowered the stiffness, the cloth obtains some freedom to move from its original position within the binding distance. The lower stiffness gets, the easier it becomes to move the cloth within the binding distance. However, you can see that if we switch the gravity off, the cloth tries to return to its original position. If the tolerance is less than the gap between the mesh surface and the cloth is not bound and can float freely. However, once the tolerance is equal to or higher than the gap, about 15 mm, the cloth is bound, and it gets pulled to its original position. Now, let's rotate the cloth so it won't be parallel to the cuboid wall and start the simulation. As one can expect, the binding is now applied only to the part of the cloth that is within the tolerance gap from the mesh surface. The part of the cloth that is further from the mesh than the tolerance gap can move freely. Our next example is the cylinder and a skirt with a waistband. First, let's turn the gravity on and set the waistband's binding tolerance to 0 and start the simulation. If the waistband diameter is larger than that of the cylinder, the skirt slides down to the floor. Let's switch the gravity off first to prevent the skirt from sliding down and set up the binding tolerance to 15 mm, distance to 33 mm and stiffness to 0.5. Start the simulation once. Stop and start again to initiate the binding. Now, when the binding is active, the waistband is holding the skirt and we can turn the gravity on. If we increase the binding stiffness, it becomes more difficult to move the waistband from its original position, and when we release the force, the garment moves back right away. Let's repeat the same steps for the skirt fabric itself. We turn the gravity off and set the tolerance to 33 mm. Distance to 111 and stiffness to 0.5. Let's also set the binding distance to 0 for the waistband so it won't move during this experiment. Let's start the simulation and try to adjust the skirt shape before the binding takes effect. When we stop the simulation after that, the system turns the wrapping on, or in other words, it remembers how the cloth triangles are positioned relative to the mesh surface. Starting the simulation again turns the binding on and the parts of the skirt that are within the tolerance gap become bound. We can modify the tolerance value and see how it affects the skirt fabric. When tolerance is set to 0, there is no binding effect, but when tolerance is over 20 cm, the whole skirt is now bound. Let's take a look at how the same approach works in Unreal Editor. When we start the simulation, for this skirt on the cylinder, the skirt slides down because of the gravity. We can turn the wrapping off, change the skirt's position on the cylinder, and save it in the new position. The new wrapping information will be saved, and the wrapping will be turned on. Let's expand the physical properties for the waistband material and note that the binding is turned off because the tolerance is set to 0. Naturally, when we start the simulation, the skirt still slides down because the waistband doesn't hold it up. Let's now set the tolerance to 10 mm and observe that the waistband is pulled to its original position. If we increase the distance to 100 mm and decrease the binding stiffness, the skirt will slide down within the allowed distance. Here we have two opposite forces, the gravity and the binding compete with each other. With the binding distance, we can control how far the bound cloth can move from its original position, and the binding stiffness controls how forcefully the binding is pulling the cloth back. When the stiffness is set to 1, the binding holds the fabric fast. Lowering the stiffness allows the fabric to move within the binding distance more freely. While running the simulation, we can hit Shift-B hotkey to toggle the binding on and off. When binding is turned off, either by using Shift-B or setting the binding tolerance to 0, we can adjust the garment position and save the garment. After that, binding will be applied to this new position. Let's take a look at how one can use close binding for human characters. Here, we've got the same skirt on a human character. Let's see how it works with a dancing animation. As we can see, the waistband can slide down during the animation. Like the previous example with the cylinder, we can turn the gravity off. Run the simulation and reposition the waistband where we'd like it to be. And then save the skirt in its new position. We can turn the gravity back on and set the waistband binding tolerance to 15 mm, the distance to 25 mm, and the stiffness to 0.5. Save the waistband material and start the simulation. As one would expect, the waistband holds better, and when we start the animation, it doesn't slide down from the waist. Here's another example. We take these jeans in uDraper and export them. Then we open these jeans in Unreal Editor. Again, the jeans are sliding down during this walking animation. One way to resolve it is to increase the waistband's friction or rigidity. Alternatively, we can apply some binding to the waistband to ensure it will hold during the animation. We can also control binding distance and stiffness to make the waistband move more realistically instead of gluing it steadfast. In the next example we have these suspenders, which can easily slide down from the shoulders. Applying some binding will hold them in place and prevent them from falling. We also have the ability to toggle binding during the simulation by pressing Shift+B. This can be useful when we want to adjust the garment position at runtime. After the garment is positioned as required, we can save the garment and turn the binding back on. Here's how suspenders behave without binding during a walking animation. And here is how they behave with binding on. Another example is this large and heavy dress. Without binding, the top part is stretched because of the dress's weight. This can be prevented by binding the top part of the dress to the torso. The next example shows how to use binding during fast animations to prevent the clothes from ripping or falling. To demonstrate this idea, we are going to use a fast kung fu animation and a stylized combat suit. Let's start with these pants. We suggest using separate materials for different parts of the garments for better binding control. In this case we have 3 separate materials for the pants, the waistband, and the cuffs. Then, we will use this shirt. Notice, we've added separate domains to the shoulder lines. When specifying domains, we specify the radius of the area that the domain will cover. Then we can specify a separate material that will be applied to that area. In this case, we have a special material called body binding, which has separate binding settings. We have also prepared separate materials for other parts of this shirt such as sleeves, cuffs, and the body. Let's open these garments in Unreal Editor. We are going to configure the pants first, so we can disable the shirt for now. Let's try the animation without binding first. As you can see, the tolerance is set to 0. Starting the simulation and then the animation. At some point the pants are getting ripped because of the fast legs movements, so there is no reason to continue this animation any further. Let's configure binding for the pants now. First, we need to use the most common pose for the animation we want to play. In this case we can use this Kung Fu idle pose. We need to start the simulation and let the garment relax. We may need to straighten the material on the character using the mouse cursor so that the material lies most naturally. At this point, we want to save the garment, so we save the new garment position relative to the character mesh in this pose. Now, we can configure the binding and start with the waistband material. The waistband is quite close to the body, so we can set the tolerance to 10 mm, and we do not expect it to move much, so the binding distance of 10 mm and 0.6 stiffness should suffice. Save this material. Next to the pants material. These pants are rather wide, and they move rather freely, so we can try to set the tolerance to 66 mm, the distance to 100 mm and the stiffness to 0.2. Finally, the cuffs, which should also have enough freedom to move, so we set the tolerance to 111 mm, distance to the maximum, which is 250 mm, and the stiffness to 0.1. By the way, let's switch the project shadow map method from the virtual shadow maps, which is in beta, to shadow maps to get rid of these strange shadows. Starting the simulation and then starting the animation. This time the pants are not breaking through the sequence. Let's enable the shirt now. We can also toggle binding in the Draper simulation component. Simulation, binding. Let's turn the binding off just to see how the garments will behave without it. It's a no-go. Turning the binding back on. This is how we set the binding for different parts of the shirt. This is not an exact science, so we can just come up with numbers based on how this particular part of the garment is supposed to move. For instance, the shoulders should not move much while the lower part of the shirt and the sleeves may move rather freely. Starting simulation and animation. The clothes hold without tearing. We can also switch the binding on and off during the simulation and animation using blueprints. Let's demonstrate this with this sequence and director's blueprint. We open the director's blueprint. Add a custom event. Call it Enable Binding and add two inputs. A Boolean and a Draper simulation structure. Now, we need to call the simulation, set binding function and then simulation, configure. Save and compile the blueprint. In our sequencer we add the Draper simulation, and the event trigger tracks. Then add events to turn the binding on or off. For this demonstration, we add an event in the beginning to turn the binding off. Then, we turn it back on somewhere in the middle of the animation sequence. Let's start the simulation and animation. We see that the binding turned off at the beginning and then turned back on when it should. Finally, we cached this simulation the same way we did in the previous tutorial and played it back when rendering the animation in a new scene.